Hi everyone, I thought I'd discuss object references today, as this is usually a question that comes up in Java interviews. So what are object references and how are they assigned? So an object reference is, as the phrase suggests, a reference to an object. So if I just move ahead here to this little simple diagram that I've drawn, you'll have, in the case of a normal bit of code where you have an object assigned to its reference. In what's happening actually behind the scenes is that the reference myObj is kept in the main method stack frame, and that reference is then assigned the object address. So when you call the constructor for the object class and you get an actual object, the reference then to that object, which is in the heap, is stored in the reference in the main method stack frame. So here we have, this is what I just put in a few bullet points here. So the reference is kept in the stack frame for the method. When the object is instantiated using the constructor, the object is kept in the heap, and the reference is updated with the address of the object that is in the heap. So then you have your reference which points to the object. And normally, as long as you have a reference to the object, like in this case, then Java will not release that memory to be used by other parts of the program. So that object will be kept there as long as you have a reference. And what we normally call this an object reference, but with respect to other types of references that I'll be discussing, this is what you normally call a strong reference to an object. Strong as in it's not weak, because we have a different type of object reference, which is an weak object reference. And more on that soon. So the whole idea that we have to understand around object references at this point for strong object references is that the standard way of instantiating an object, where you have your constructor called and then you assign it to a variable of that class type, that is called, that assignment, that is a strong reference to the object. And it's strong in the sense that as long as that reference is valid and exists, then that object will not be touched by the garbage collector of the virtual machine, which normally is looking for objects with no reference. And what it does then, it releases that memory for use by the program for other objects. So this is why it's called a strong reference. And this takes us nicely into the next point here around object references and how they're removed. So an object reference loses its when you reassign it to null or you reassign it to another object, then the reference to the original object is lost. Another way to do it is when the method exits, then that reference is no longer in scope. Again, the reference is lost as you exit that particular method. Particularly, we know for local variables, once the local variable is out of scope, the program that memory in the heap is now eligible for garbage collection. It's not referenced by anything else. So if it's no longer referenced by the method, then the garbage collector, when it runs, will release that memory so that another variable, when it's created, another object when it's created, will use that memory, and it will be given, that address will be passed on to another object reference. And again, here's a small diagram that talks about what is happening behind the scenes. So let's say we assign null to this object, my obj, this object reference. The object itself now has no reference on the heap, and this will then be released when the garbage collector runs, and it will be made available to other object instantiations so that that memory can be used for other references. So I think this is a good time to stop, and I'll carry on in our next video. We'll talk more around the other types of object references. But suffices to say, before I wrap up here, what is the issue here? Why does it make it? What makes it so important to understand the object references? Well, in a nutshell, there are cases where even though you have an object reference, there are cases where we would still want the object to be released back to memory when the garbage collector runs, or if the Java virtual machine needs memory. And that's again normally why there are cases where, and there are definitely cases where this is possible, where this can happen. So as I mentioned to you early on, what we just discussed were strong object references, but we can use other types of object references that would allow the object itself to be removed. If the Java virtual machine needs memory, those objects would be removed, even if there's a reference to them, but it wouldn't be a strong reference, and we'll come to that later on. And also, there are other cases where whenever the garbage collector runs, that object will be removed. So not necessarily when it needs memory, but whenever the garbage collector runs, it would release that memory. And as I said, the previous slides talked about the standard object reference or the strong object reference. In those cases, that object would stay in the heap as long as there is an object reference there for it. But there are other types of object references, and we'll come to that soon, where we can allow those objects to be released from the program when there are urgent requests for memory, or whenever the garbage collector runs, even if there's a reference. So this is what we'll cover in the subsequent videos. But for now, I think this is a good introduction to the object references themselves, and we'll carry on soon with the more details on other types of object references. Thank you very much.